All right, you are welcome again. Today, we want to consider a very important and very powerful topic in differential equation, which says exact equation. Okay, now let's go straight to the point. The question says, show that this equation is exact and solve. 2xy minus 3x squared in bracket dx plus x squared plus 2y in bracket dy equal to 0. This is a differential equation. And the question says we are to show that this equation is exact and we are to solve it. You get it, right? Good. Please, I want you to pay attention. I'm going to take my time and explain this exact equation very well, to the point that anywhere you come across exact equation, you will know exactly what to do. It will not be confusing. I am here to make you understand, and I promise not to waste your data. Just follow me gradually. I'm going to explain in details. Now, what do we mean by exact equation? For instance, when we have a function u of x and y, let's assume we have a function u of x and y. And when we differentiate this function u partially with respect to one of the variables, let's say x, we are going to have another function. Now let's name that function m. And then when you differentiate the original function again, u, partially with respect to the next variable, which is y, we are going to still come up with another function. Now let's call this n. You get it, right? So that means here we have the partial derivative of u with respect to x give us m. And then the partial derivative of u with respect to y gives us n. Now the sum of these derivatives. Now, we have two partial derivatives. When we bring them together, we get the sum, right? Now the sum gives us the u is equal to m of x comma y dx plus n of x comma y dy equal to 0. You get it, right? Do you understand this? The partial derivatives, we bring them together, it gives us their total, right? Now, this total now is a differential equation. You know why? Because it involves its derivatives. An equation involving what? Derivatives. Now, we said that this differential equation is exact if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Hello? Now, let me come again. When you differentiate m partially with respect to y, and it gives you the same as when you differentiate n partially with respect to x, we say that the equation where this m and n is coming from is an exact equation, provided that these partial derivatives of m with respect to y and of n with respect to x are continuous functions of x and y. Now, let's use the question we have and explain this in a better way. Now, let's go. We have 2xy minus 3x squared in bracket dx plus x squared plus 2y in bracket dy equal to 0. This is the question we are given, and we are asked to show that this equation is exact. How are we going to do this? The first thing we are going to do is we are going to examine the equation very well. Examine the equation very well. The part that is having the x, we are going to call it m. You get right? Now, the part that is having the y, we are going to call it n. Hello? This is a differential equation. The part or the section that is having the x, we are going to name it m. And then the section or the part that is having the y, we are going to call it n. All right? So here, that means we're going to say the part that is having the x. What is the part? In the equation, we have 2xy minus 3x squared is the part that is having the x, right? So that means we're going to say that m is equal to 2xy minus 3x squared. Is that correct? Good. Now, the next section is the part that is having the y, which is what? X squared plus 2y. So here we say that n is equal to x squared plus 2y. All right, good. So the next thing is we are going to differentiate m partially with respect to y and n partially with respect to x. So when we differentiate m partially with respect to y, that means we are going to have 2x. Partial derivatives is talking about you hold every other variable constant and differentiate the one you want to differentiate. Okay, you hold every other variable what? Constant. Now, so as we differentiate m partially with respect to y, here we have 2x. And then the other side, we have minus 3x squared. There is no variable y in it. So this minus 3x squared is a constant. And then the derivative of a constant is 0. So here we have only 2x. Now going to n, we differentiate n partially with respect to x. So here when we differentiate x squared with respect to x, it's going to give us 2x. And when we differentiate plus 2y partially with respect to x, since there is no x variable in it, so this plus 2y is the same as a constant. And then the derivative of a constant is 0. You get? So here the derivative or the partial derivative of n with respect to x is equal to 2x. And then the partial derivative of m with respect to y is equal to 2x. So here we say that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, equal to 2x. Hence, the equation is exact. So now, we have shown that this equation is exact. What is the next thing for us to do? The next thing for us to do is to solve. You are going to do what? We are going to solve this. Now let's go. We have 2xy minus 3x squared in bracket dx plus x squared plus 2y in bracket dy equal to 0, right? Good. Now, let's go. How can we solve this? How can we solve this? Now let's go. Initially we say we have a function called u of x comma y. Now, let u of x comma y be a function such that the partial derivative of this function with respect to x will give you m, and the partial derivative of this function with respect to y will give you n. Hello. Now, pay attention, please. We say, let's have a function. This is the function we are trying to figure out. Let's assume that there is a function. And then the partial derivative of this function with respect to x, it gives us m. And then the partial derivative of this function with respect to y, it gives us n. You get right? Good. Now, let's go. The partial derivative of u with respect to x is equal to m. And then previously, what did we say that m is? We said that m is the part that is having the x, right? M is the part that is having what? The x. So in our equation, which part is having the x? We have 2xy minus 3x squared. So that means we're going to say that the partial derivative of u with respect to x, which is the same as m, is 2xy minus 3x squared. Now let's call this equation 1. All right, good. Now let's go again. We have the partial derivative of u with respect to y is equal to n, right? And then we say that n is the part that is having dy. That n is the part that is having what? Dy. So what part is having the y? We have x squared plus 2y. Now let's call this equation 2. Now please pay attention. Now the solution that we are looking for is a function. Hello. The solution we are looking for is a function. One function, we can call it u of x comma y, such that when you differentiate this function partially with respect to x, it's going to give you 2xy minus 3x squared. And then this same function, if you differentiate it partially with respect to y, it's going to give you x squared plus 2y. So that is the function we are looking for. So that is the solution. So we want to find an equation or a function that this function, we can call it u. And then when we differentiate this function partially with respect to x, it's going to give us 2xy minus 3x squared. And then this same function, when we differentiate it partially with respect to y, it's going to give us x squared plus 2y. Now, we are looking for one function that has these two properties. So here, we can choose to use equation 1 to find this function, or use equation 2 to find this function. So whichever one we choose to, we will arrive at the same answer. And then in this video, I'm going to use two of them. So we are going to pick the first equation and solve and see if we will arrive at the function, and then also go back, pick the second equation and see if we will also arrive at the same function. All right, I think it's okay, so that with this practice, you'll be able to know how to do it very well. Now let's go. Let's pick equation 1. Now equation 1 says the partial derivative of u with respect to x is equal to 2xy minus 3x squared. This is equation 1, right? Good. You know, this is an equation, or this is a function that was differentiated partially with respect to x. So we want to find the main function. And then you see that it was differentiated. So to find the function, we remove the derivative. Hello. To find the function, we do what? We remove the what? The derivative. And for us to remove the derivative, what do? We integrate, or we take the integral of that function. Hello. Now, you know, in this equation now, this equation 1, it was partial derivative of u with respect to x. So for us to remove this derivative, we integrate it with respect to dx. I think you understand what we're trying to say. The function we have is the partial derivative of u with respect to x. So we want to find a function u. And then this function is having derivative. That means we have to remove and take away the derivative. So for us to do away with the derivatives, we have to integrate it. So the derivative will go, right? Good. So we integrate it with respect to dx, with respect to x, right? Good. Now that means we're going to have the integral of the partial derivative of u with respect to x dx equal to the integral of 2xy minus 3x squared dx. All right, so this partial derivative of u with respect to x dx, so when you integrate, it will just give you the function u. All right, so here we're going to have u, and then the next side we integrate 2xy with respect to x. What is it going to give us? That means we're going to have x squared y. Hello, we're going to have what? X squared y. We integrate x, we take y as a what? As a constant. So when we integrate x, 2x, the integral of 2x is going to give us what? X squared. So here we have x squared y. Is that true? Yes. Now, the next part, we integrate minus 3x squared with respect to x. That is going to give us minus x cubed. Minus x cubed. Now, you see that this function is of x and y. Hello? Is of what? X and y. And we integrated with respect to x. So to show that we did not neglect or we did not do away with y, we know what we are doing. Y is involved in our function. So we're going to have plus t of y. Hello. So we're going to have what? Plus t of y. Now let's go. We are looking for a function u such that this function, when you differentiate it partially with respect to x, it's going to give you 2xy minus 3x squared. And when you differentiate it partially with respect to y, you are going to have x squared plus 2y. Now, here we are beginning to have a function like that, which is u is equal to x squared y minus x cubed plus t of y. So t of y is the only thing that is holding us now. So we want to know what is this t of y. Now let's go. We are going to have this function that we have now, this equation now, we are going to call it equation 3. So that means we're going to say that u is equal to x squared y minus x cubed plus t of y. Let's call it what? Equation 3. This equation that we have now, please permit us, let's differentiate it with respect to y. Partially, let's differentiate this function, this equation 3, partially with respect to y. I know what I'm trying to say. Why do we differentiate it partially with respect to y? We have t of what? Y. It's because of the t of y we differentiate with respect to y. All right? Good. Now, that means we're going to have the partial derivative of u with respect to y is equal to, when we differentiate x squared y partially with respect to y, what are we going to have? We're going to have x squared. And then minus x cubed. We are differentiating partially with respect to y. So there's no y variable here. So this minus x cubed is a constant. So the derivative of a constant is what? Is 0. And then remaining this t of y. So when we differentiate this t of y, that means we're going to have t prime of y to show that it is in a derivative form. It is in a what? Derivative form. All right? Good. Now, let's call this equation now equation 4. Let's call this what? Equation 4. From here, let's go back to equation 2. What do we have in our equation 2. Our equation 2 says the partial derivative of u with respect to y is equal to x squared plus 2y. Okay, and then what do we have now? We have in our equation 4, the partial derivative of u with respect to y again is equal to x squared plus t prime of y. Hello. Now, let's study these two equations very well. Equation 2 and equation 4. The partial derivative of u with respect to y is equal to x squared plus 2y. And then the partial derivative of u with respect to y again is equal to x squared plus t prime of y. So here we have the partial derivative of u with respect to y in equation 1, the same partial derivative of u with respect to y in equation 4. And then we also have x squared and we also have x squared. So that means these two equations is what? Is the same. But we don't know the t prime of y. We can say that t prime of y is equal to what? 2y. Yes. Yes. Now let's go. Since we are correct here, we say that t prime of y is equal to 2y. But what we are looking for is not t prime of y, because this t prime of y is talking about the derivative. So what we are looking for is just t of y, not t prime of y. And then this t of y is in a derivative form, right? So that means we're going to remove the derivative. So when we remove the derivative, that means we have the what? The t of y that we are looking for. So that means we're going to integrate this t prime of y with respect to y. So that means we're going to have the integral of t prime of y dy is equal to the other side. We integrate also with respect to y, the integral of 2y dy. So when we integrate this t prime of y, what is going to give us? It's just going to take away the derivative. Then we have our what? T of y equal to, and then when we integrate 2y, what is going to give us? It's going to give us y squared plus c. We're going to have what? Y squared plus c. Let's call this equation 6. Let's call this what? Equation 6. Now let's go back to equation 3. Equation 3 where we are having the original function, we see u of x, right? So in equation 3 we have u is equal to x squared y minus x cubed plus t of y. And then here we know what t of y is. That means we will substitute equation 6 into equation 3, because now we have solved and we obtain what t of y is. Okay, so substituting here now, we see that u is equal to x squared y minus x cubed plus y squared plus c. Yes, this is the solution. This is what we are looking for. So this is exactly how to solve an exact equation. Now hold on, let's check whether what we solve is correct. When we started, I told you that we are looking for a function u of x comma y, that when you differentiate this function partially with respect to x, it's going to give you 2xy minus 3x squared. And when we differentiate this same function partially with respect to y, it's going to give you x squared plus 2y. So let's see. Let's differentiate this partially with respect to x and with respect to y. Let's see whether it's going to give us the equation that we have in equation 1 and equation 2. Now let's go. Here we have u is equal to x squared y minus s cubed plus y squared plus c. Let's differentiate this u partially with respect to x. What are we going to have? When we differentiate x squared, it's going to give us 2xy minus When we differentiate x cubed with respect to x, it's going to give us 3x squared. Now, when we differentiate y squared with respect to x, is a constant. It gives us 0. When we differentiate c, is a constant. It gives us what? 0. So the partial derivative of u with respect to x is giving us 2xy minus 3x squared. It's giving us what? 2xy minus 3x squared, which is the same as what we have in our equation 1. And then let's go again. Partially with respect to y. So we'll go again. That means we are going to differentiate this x squared y partially with respect to y. When we differentiate, what is it going to give us? It's going to give us x squared. Is that true? And then when we differentiate minus s cubed with respect to y, is a constant. It gives us what? 0. Now then when we differentiate y squared, it gives us 2y. When we differentiate c, it gives us 0. So the partial derivative of u with respect to y is equal to x squared plus 2y, which is the same as what we have in our equation 1 and equation 2. Yes, we are correct. Now let's go. As I promised, I said we used equation 1 to get our function, which is u of x comma y, right? Good. I want us to go back again. Let's use equation 2 and see if we are going to get the same function. All right? Now let's go. In our equation 1, we have the partial derivative of u with respect to x equal to 2xy minus 3x squared, which is equation 1. And then we also have the partial derivative of u with respect to y, which is equal to x squared plus 2y. We call this equation 2. Now, let's go. We're going to pick equation 2 now. Now, we are looking for a function u of x comma y such that when we differentiate it partially with respect to x, it gives us this equation 1. And when we differentiate it partially with respect to y, it gives us this equation 2, right? Now, let's go. Here we choose equation 2 to work with. And then this equation 2 is talking about the partial derivative of u with respect to y. And we are looking for u. And then this u is partially differentiated with respect to y. That means we are going to take away the partial derivative. So for us to take away the partial derivative, we integrate with respect to what? To y. Because it was partially differentiated with respect to y. So we remove the partial derivative with respect to y by what? Integrating with respect to y. Okay, good. Now let's go. That means we're going to have the integral of the partial derivative of u with respect to y dy equal to the partial derivative of x squared plus 2y in bracket dy. All right, good. In the left hand side, when we take the integral, it will just take away the derivative and give us the function, which is what? U. And then in the right hand side, when we integrate x squared with respect to y, it gives us x squared y. Hello, integrating a constant, it will introduce the variable to it. Is that true? Yes. So here we have x squared y plus. Now when we integrate 2y, what will it give us? It will give us y squared. Now, this is talking about u, the function u of x and y, and we integrated with respect to what? To y. And then the function is having x in it. We did not neglect the x. So that means we're going to have plus t of x. That means we're going to have what? Plus t of x. Now let's call this equation 3. Let's call this equation 3. So now, we have found the function we are looking for. Which function? U of x. And then the u of x is what? is x squared y plus y squared plus t of x. But we don't know what t of x is. Hello? But what? We don't know what t of x is. So that means the only work we need to do now is to find what t of x is. So when we find what t of x is, we bring it here, then we are done. Okay? Now let's go. Now look at it very well. This is u of x, right? Good. That means we are going to differentiate this u partially with respect to x. You know why? Because of t of x. We are looking for what? T of x. That's why we differentiate partially with respect to x. So when we differentiate partially with respect to x, we're going to have the partial derivative of u with respect to x. So when we differentiate x squared y with respect to x, what is going to give us? It's going to give us 2xy. And when we differentiate y squared partially with respect to x, there is no x in it. So we will take this y squared as a constant. So the derivative of a constant is equal to what? 0. It will disappear. And then remaining this t of x. So the derivative of this t of x will give us what? T prime of x. To show you that it is in a derivative form. We don't know what this t of x is, but we take the derivative of it. Then we tell and we show that it is in a derivative form. Hello. Good. Now let's go. Let's call this equation 4. Equation 4. Now let's go back to our equation 1. What do we have in our equation 1? Equation 1 says the partial derivative of u with respect to x is equal to 2xy minus 3x squared, which is equation 1. And then what do we have in our equation 4 now? Equation 4 says the partial derivative of u with respect to x is equal to 2xy plus t prime of x. Hello? 2xy plus t prime of x. Now, merely looking at this equation, we see that they are the same. So this implies that t prime of x is equal to minus 3x squared. Alright, good. So here we have t prime of x equal to minus 3x squared. Let's call this equation 5. When we started, we came to a point that we are looking for just t of x. You get it, right? But now what we have is t prime of x. That is to say that the t of x that we have is in a derivative form. T prime of x. So for us to find the t of x we are looking for, we have to remove the derivative. So for us to remove the derivative, we do what? We integrate with respect to x. So that means we're going to integrate this equation 5 with respect to x. So that means we're going to have the integral of t prime of x dx equal to the integral of minus 3x squared dx. Okay? So here, when we integrate t prime of x dx, it will just take away the derivative, right? That means we're going to simply have our t of x. And then when we integrate minus 3x squared with respect to x, what are we going to have? We're going to have minus x cubed plus c. We're going to have what? Minus x cubed plus c. Hello? Yes. So here we have t of x is equal to minus x cubed plus c. Let's call this equation 6. So in equation 3, we are actually looking for what? Looking for t of x. We're actually looking for what? T of x. And we have found our t of x. So that means we're going to substitute this equation 6 into equation 3. So our equation 3 says u is equal to x squared y plus y squared plus t of x. Now we have found what t of x is. So replacing it here, we are going to have u is equal to x squared y plus y squared minus x cubed plus c. Hello? Yes, this is the answer that we have. So we solve the first one and we obtain our u. Following the second method or following the second equation, we also obtain the same u. All right? Yes, thank you very much. This is exactly how to solve exact equation in a differential equation. All right? Yes, thank you. Let's take more examples. Stay blessed.